at more characteristics of polynomials and look at their graphs and their zeros. So in order to find the zeros or the x-intercepts of a polynomial, sometimes you need to factor it. So let's go back to practicing factoring here. So this factors into x plus 3, x plus 5. This one factors into x plus 6, x minus 6. This is difference of squares. This one you should factor out a greatest common factor first. So it's going to be 3x. You can take a 3x out and then you're left with x plus 2, and I can't factor that any further. And number 4, I could factor out a greatest common factor and do x to get x squared minus 7x minus 18. And you should always check to see if you can still factor what's left. So I can factor out and write x minus 9, x plus 2. Over here, for number 17, you can take out a 2x out of all three terms. And then you can still factor out this part. So still keep the 2x on the outside, and you're left with x plus 2 and x plus 3. And then this one you can factor out an x out of all three terms, actually an x squared. So it's going to be x squared minus x minus 6. And then you can still factor out further. And this one, I'm going to take out a negative 3. I take it out negative 3 because I want my leading coefficient to be positive. It just works easier for me when I'm factoring. So x squared minus 6x plus 9. And so this factors into x minus 3 or x minus 3 squared. So just a good review on factoring, because we're going to need that later on to actually find the zeros. So to find the zeros, a zero is where it's going to cross the x-axis. You can use the zero product property. So if we set y to be 0, if y is 0, that means that it's crossing the x-axis. So remember when we did quadratics, to solve a quadratic we use the zero product property. We can solve it for polynomials, all polynomials. So I'm going to set x plus 1 equal to 0, x minus 1 equal to 0, and x minus 3 equal to 0. So I have zeros of negative 1. I'll graph this in different colors so you can see it better. I have zeros at negative 1, 1, and 3. So this polynomial is a cubic, it's degree 3, and it's going to cross 3 times. And I know the leading coefficient's positive, because if I multiply x times x times x, I get a positive number. So it means it's going to increase from left to right. So it's going to look something, oh, that was not great. It looks something like this. This is a sketch. Okay, it's not rough. We can use our calculator and be more exact. And then I'm going to use the zero product property again, and the zeros are negative 2 and 3. So I'm going to make a point at negative 2 and 3. And again, the leading coefficient is positive. It's a quadratic. We know it's going to open up. Actually, I know the y-intercept is negative 6, so I can actually mark that too as well. So it's going to look something like this. And then the last one, don't forget about this 0. This could be 0 as well. You could set x equal to 0. That's a factor. And then I have 2 and I have negative 5. So I'm going to plot 0 to negative 5. It's a cubic, and it's going to go up from left to right because the leading coefficient's positive. Okay, then down here you can go backwards if you know the linear factors. If you know that x or negative 4 is a 0, then you know that x plus 4 is a factor. If you know that x minus 2 is a 0, you know that x plus 2 is a factor. And then x minus 1 is a factor. So to write in standard form, we need to get rid of the parentheses. We need to do the distributive property. So I'm going to do the distributive property on this part, x squared plus 6x plus 8. And then I'm going to multiply that by x minus 1. So this is going to be x cubed plus 6x squared plus 8x minus x squared minus 6x minus 8. So I'm writing standard form means to combine like terms and write it in highest to lowest degree. So there we go. So I'm going to go ahead and set up the next one too. So for the next one, you'll notice that I had 0 at -4, so I wrote x plus 4, -2, x plus 2. And if you have a 0 at 0, then it's just going to be x, or x plus 0, or x minus 0. And then I FOILed this out, and I multiplied everything through by x. So I really should end up with y equals, because it's a function. I really need to put y equals. So you have, when we did a quadratic, we had a minimum and a maximum. This time, when you have a cubic or a 4th degree, 5th degree, you could have what's called a relative minimum or a relative maximum. There's no true min or max because it's extending infinitely. So the relative min is a dip point. This is a mountain point within the function. So what you're going to do is you're going to put this in your graphing calculator. So you put this into your y equals. Now I put it in my calculator and it looks something like this. Okay, try to go on a negative, try to put your window at -10 for x to 10, and then -10 for y, scale up to 10 and go up by ones. So it's going to look something like this. So this point right here is going to be your relative max. This point right here is going to be your relative min. So I'm going to, there will be a calculator tutorial on how to find the relative min, relative max on your calculator. But if you think about making a vertical line through the relative min or max, when you do the left-hand side of the max, here's the left-hand side. Here's the right-hand side of the max. If this is your minimum point, here's your left-bound part. Here's your right-bound part. Then the second one, the graph looks something like this, which I'm not even going to put in the coordinate. I'll just do a sketch of it. The graph looks something like this. Oops. There's a little more curve to it, so it went like this. So this part was your relative min. This part was your relative max. So again, if you draw a vertical line through the relative min and the relative max, this is the left-hand side of that min. This is the right-hand side of this min. This max has a left-hand side right here, and this max has a right-hand side. So again, it's just another option on your calculator. You're not going to use the trace function. We actually want you to calculate that. So multiplicity of a zero. If a linear factor of a polynomial is repeated, then the zero is repeated. So a repeated zero is called a multiple zero. A multiple zero has multiplicity equal to the number of times the zero occurs. So if you look at this first one, first of all, let's talk about, this is going to be a 1, 2, 3, 4. This is going to be a 4th degree polynomial. It's degree 4 because this part right here is degree 2. So the zeros are going to be at x equals 2, x equals -1, and x equals 1. So The multiple zeros are the zeros that happen more than once. So there's a multiplicity of 2 right here. So x equals 1 has a multiplicity of 2. Letter B. Well, okay, look at how letter A and letter B are a little bit different. So A is in factored form. B, I need to factor it. So I can do that. I can factor out a greatest common factor. Then I can factor out, this is going to be x minus 2 times x minus 2, which we can write this as x minus 2 squared. So this is a cubic function. So this function has a 0 at 0. Don't forget the x on the outside. And it has a 0 at 2, and with a multiplicity of degree 2. Multiplicity of 2 because the degree is 2. So let's just recap that. This is the same way of saying the same thing. So if you say that negative 4 is a solution to this polynomial, or to this function, it's the same thing as saying it's an x-intercept. It's the same thing as saying it's a 0. And it's the same thing as saying x plus 4 is a factor. So these are all interchangeable. So we can ask you solutions, x-intercept, zeros. Is this a factor? You're doing the same thing. So if x plus 3 is a factor, it means that x equals negative 3 is a 0. It's a solution, and it's an x-intercept. And we can get these by doing them on our calculator, or we can get these by factoring and using the zero product property.